think there'll be any of those around here. She says.
Do without those. You could well do without those.
Okay, thanks. You need the clap, hey? Good afternoon and welcome to the ESI Africa studio here at African Utility Week. I'm Claire Falkvang. I'm the editor of Metering and Smart Energy International. And with me today we have Dr. Peter Smith, who is the Global Technology Manager for Shell. Peter, thank you so much for taking the time to meet with us this morning. I was wondering, obviously as we were speaking earlier, you know that I'm not an expert when it comes to anything oil or lubrication related, but I was wondering if you could talk to us about some of the technical challenges that arise from the incorrect use of turbine and or transformer oils.
Sure. So turbine generation, transformer, insulating oil use has been getting on for 100 plus years. The requirements for the older equipment typically had relatively low temperatures, reasonably low severity, and a reasonably short oil life, and the accepted norm there was you'd change the oil at frequent intervals. With the latest generation of turbines and transformers, typically customers are looking to get longer oil life from their oil fill, and of course they want associated asset life increases as well. So typically they want the asset to operate at a higher level of efficiency for a higher level of time, and they also want to know that there's less risk of an unplanned shutdown. So sorry, that was the flight. Yeah. So if a customer is using an oil, whether it be in a turbine or a transformer, they're interested to understand, is the oil going to resist degradation and degradation product formation, because that basically limits the life of the asset. So it's all about maximizing asset performance and asset lifetime. So for example, on the turbine side, turbine oils historically used to be based on crude stroke mineral oil based conventional hydrocarbon products, and they have relatively short lives, and typically once they reach the end of the life, the oil starts to fade rapidly. It forms sludges and oil insoluble deposits. They can block filters and they can form deposits in bearings, the rotating parts of the turbine, and ultimately that means the turbine can fail in a relatively short space of time.
Okay.
So on the transformer side, I'll give you the full story here. Sorry, I'll just sort of give you the full story, and then you can edit this back to the more compelling sound bites, hopefully. So on the transformer side of the industry, in the transmission and generation side, transformers typically have to operate for 30 to 40 years. So the oil has to last and to operate successfully for 30 or 40 years. Typically the amount of additive in the oil is less than 1%. And so it's 99% base oil. So base oil criteria and selection is critical for both turbine and transformer operation. So if you want reliable equipment and asset life, you need to select a premium tier insulating or lubricating oil. So for transformers, some of the issues that customers see are corrosive sulfur. So some of the historic oils used had high sulfur contents. Some of those sulfur species in a transformer could actually become corrosive, and you could react with the copper to get conductive copper sulfide formed. And if you get conductivity in an insulating oil, the transformer fails. So it's all about how do you actually take an asset and extend the asset life by selecting and optimizing the lubricating and insulating oil. So a lot of this is about total cost of ownership of the asset and what that means by selecting and identifying the best oils.
And correct me if I'm wrong, but you're able to test the oil over the lifetime of the product to see how it's performing, to see if there are changes or warning signs in how the oil is behaving, if I can put it that way.
Exactly. So a turbine oil has got to last in the field for 5 to 10 years. Transformer oil is 30 to 40 years. Of course, in the laboratory, as a formulator of finished oils, I don't have the luxury to run a laboratory test for 5 to 10 years or 30 years. So what we need to do and what we can do is we can run accelerated aging tests in the laboratory. So we would take our candidate optimized oils and we will run them under severe accelerated conditions. So we increase temperature, we blow air or oxygen through the oil, or we can add catalytic metals. All of that means that I can simulate years of severity in the end application in my laboratory in days, weeks, months, potentially up to a year for some of the longer running tests.
Okay.
So by increasing the severity of the laboratory test, we can correlate and predict the proven field performance in the field.
So what are the key considerations that you need to take into account when you are choosing an oil that is going to provide you with the optimal performance from your asset?
Yeah, thanks, Claire. That's a good question. So there's two key drivers. One are international specifications. So there's a raft of international specifications such as ASTM in the Americas, ISO globally. For transformer oils in Europe and Asia, it's the IEC, the Institute of Electrochemical Committees. Those specifications define oil properties and oil parameters, and if you like, they're the basic set of performance parameters you need to meet. The second list of criteria comes from the original equipment manufacturers, so the likes of the global manufacturers, whether they be turbines or transformers. And typically they'll have a specification over and above the industry specification because they need to be sure that the oils aren't just designed to meet the requirements, but they're actually going to work in their equipment that could be more severe over longer time frames. So the initial drive would be to have an oil that meets the industry specifications that are getting more and more severe, and then even more critical are to make sure it meets the OEM and utility company specifications. And again, most of the OEMs, most of the utilities take the simple industry standard and they bolt on additional, more severe criteria. So for an oil to pass both of those types of specs, it has to be very high performance, and not all oils can do that. So the key message here is not all oils are the same. All oils in service will degrade over time, but what we as formulators of lubricants can do is we can slow down that rate of degradation. So by optimizing the base fluid, by optimizing the additive system, I can actually extend and slow down the rate of oil degradation in service and give a longer oil life and then potentially a longer asset life. So it's all about rates of chemical reactions at the root cause, but at the customer perception level, it's all about, is their asset performing reliably? Is it performing without undue maintenance? Is it going to meet their next planned maintenance schedule? So it's all about exceeding specifications. So many oils claim to meet specifications, not so many oils exceed specifications.
Okay.
And when we start to look at some of the accelerated aging tests in our laboratory, we'll take so-called approved industry standard oils and compare them with some of the top tier oils that we're now looking to develop. And we'll see clear performance differences because the industry standards, like I mentioned, are relatively simple to pass and achieve, but some of the other specifications are much more severe. So not all oils are the same. It's not just a case of looking at a technical data sheet. Customers really need to talk to their oil suppliers about what's the chemistry, what's the technology in those formulations, what type of laboratory testing has been undertaken, what sort of customer work has been undertaken to get the oils endorsed and approved, what field trial data is there available to support that new oil. So typically from a new oil, from the idea through to a commercial product, we're talking of 5 to 6 years. So a couple of years in the laboratory doing simple testing, probably then acceptance testing with OEMs and utilities for another 1 or 2 years, 1 or 2 years of field trial. So that gives us 5 to 6 years before we go from the idea to a product we can commercially launch.
So if I can ask, how much influence do utilities have on the products that you are developing and the standards that you are working toward? I mean, are they as influential as, say, the manufacturers, or are they just a significant part of a bigger chain?
Again, yeah, thanks for that. That's another very good question, actually. You're really getting the questions in very well here. So they've got two different mindsets. So the OEMs are very much thinking about an oil that will last long enough to exceed the warranty period for their equipment.
Okay.
And typically that's of the order of a number of years. So a relatively short time period. If you look at what the requirements of the utility company is, they're actually operating that equipment for 10, 20, 30, 40 years. So they're very much interested in the longer term proven performance over a much longer time frame. So OEMs, yeah, a few years and have fairly demanding specifications. More and more utilities now want even more demanding specifications to know and understand that the latest generation of oils will actually meet their 30 to 40 year time limit.
Okay. So you raise a very interesting point, and that is the newer technologies and the newer developments that are happening within your field. Talk to me about that.
Yes, so if we look at the types of products, the types of oils that have been historically used versus the latest generation. So the early historic products were typically based on mineral oils that you get by refining crude oil. And if you think about crude oil, it's limited in its long-term availability. It's a limited resource. It's in many ways a chemical soup. So it's got a wide range of chemical functionalities. You need to purify and refine that to get an oil you can use for insulating or lubricating uses. So a lot of effort to try and turn what is a crude, impure product into a finished lubricant with limited performance. Shell is very much advocating and promoting the use of what we call gas-to-liquid technology-based lubricants and insulating fluids. And this is where we start with natural gas, which is a single carbon methane unit. We oxidize that to carbon monoxide, we put hydrogen in, we have what's then called synthesis gas. We can then do what's called, there's a lot of chemistry here, sorry. We then do what's called Fischer-Tropsch synthesis to recombine the carbon atoms back together. And basically we make a manufactured hydrocarbon, so it's a manufactured mineral oil. And because it's a manufactured hydrocarbon, it's got unique differentiated performance over and above conventional mineral oil derived products. And the other very nice benefit of using gas to liquids technology is I mentioned the limited availability and lifetime of crude oil derived products. If we look at natural gas as a resource, in terms of its current production and usage, the predictions are there's probably several hundred years of resources available. So it's a long-term, globally available feedstock to make tightly defined lubricating and insulating oils that will give utility companies and OEMs optimized asset lifetimes and protection.
So effectively you are creating something, almost a bespoke offering with very specific chemical properties depending on the application.
Very much. If you think about the assets themselves, these are engineered products that are always engineered to tightly defined tolerances. And you can think about GTL-based hydrocarbons for lubrication and insulating applications as being manufactured under very closely defined tolerances in the same sort of way. So you'll end up with unique performance and features from the tightly defined chemistry. So by knowing and understanding and controlling the chemistry, we can actually arrive at a finished product with well-defined chemistry and well-defined consistent performance.
So just the right kind of characteristics for the
Ideal
application.
for the customers and for the application. And as we look at the applications, typically the applications of tomorrow are more severe than today. You know, they're getting smaller, so the oil stress per unit oil volume is going up. Typically they run hotter. They're typically running at 100% and overloaded conditions, whether they be turbines or transformers. Customers want them to run for longer. So basically the oil is the lifeblood of the asset, so the oil needs to be better. The old products of yesteryear, the so-called conventional products, are okay for classic equipment, but if you've got the latest generation of equipment and you want to get the maximised oil life from that, you need to use the best type of oil.
So don't stint on your investment in your oil.
Not all oils are the same, and don't stint on the oil that you select. And I would also advocate that customers are very careful on their oil condition monitoring, because if you're going to have an expensive asset, you're putting in a premium product. How do you know that the oil is maintaining its performance if you don't do some sort of frequent oil condition monitoring and benchmark the performance of that oil? You don't know whether you're going to achieve the life of the oil that you want. So it's a bit like we as humans going to the doctors for a health check. You need to do the health check with your equipment, so you need to do some oil condition monitoring to understand, typically once a year is enough, what's the health of the oil at 1 year, 2 years, 3 years from the first fill, and you can benchmark and trend and start to see whether there's anything starting to go wrong with the equipment, oil-related issues before they become serious, so you can start to take preventive, corrective actions before there's a failure.
Peter, unfortunately, that's all we have time for today, but thank you so much. I feel like I've learned so much, and I always believe that a day where you haven't learnt anything is a day wasted, so thank you very much.
It's been very enjoyable. Thanks for your time and your patience. You know probably more chemistry than you wanted to know now.
No, thank you very much. It's been fantastic. So from me, Claire Falkvane at African Utility Week, thanks so much for watching.
Okay, thanks. Hopefully you can cut something out